between vapor, water, and ice? Think. You have your answer, right? And I know you got it, because vapor is a gaseous state of matter, of water rather. Water is a liquid state of water, and then the ice is a solid state of water. Now in this video we're talking basically about states, and as a result, in a wider concept, we're talking about what? States of matter. That's basically what this third episode will be about. And then we'll also be talking about kinetic theory, atoms, moles, ions, and so on and so forth. So take a fork and your spoon and dig deep into the exotic meal of chemistry. So my name is Anthony Nathaniel, and let's delve into the matter. Now let's start from kinetic theory. Now before we explain why you have vapor and you have water and you have ice and so on and so forth, let's understand what kinetic theory is. Kinetic theory basically was a theory that was a foundation of chemical understanding. Different laws were set up by the knowledge and adherence to the kinetic theory. And basically, kinetic theory is basically the theory that says that whenever you have a substance, that substance consists that, and it's a runoff from the particulate nature of matter, which you'll be doing in your physics classes, not majorly your chemistry. But in summary, basically your particulate nature of matter says that matter is consisting of particles, and those particles, which we've talked about in the previous series, are the atoms, right? The atoms and molecules. But today we'll be delving further into that, and we'll be picking up today's lessons from that. If you've not watched that episode, you can delve back into to watch it. That episode was about state atomic theory. So but today we're talking about states of matter. So let's move on. Now, as I mentioned earlier, kinetic theory is basically a theory that forms the foundation of most theories and laws in chemistry. So, and basically what it says, without keeping you in much suspense, it states that matter consists of particles, and these particles, they are moving constantly. So either they are moving rotation, or they are moving in translation. Either they are moving in a straight line, or they are moving in curved lines. And basically those curved lines are called rotations. And then when you combine these different motions together, you have what is known as random motion, also specifically known as Brownian motion. And just to digress a little bit, the famous Albert Einstein based most of his one of his theory on Brownian motion. So I have forgotten which theory was that, but he also referred to Brownian motion. But then Brownian motion is basically a proponent and the advocate of kinetic theory, and it states that whenever matter is suspended or is in a free suspension, so those matter, they always move randomly, and it is even observed whenever you see particles of dust in the air. So these dust are moving in random manner. So this kinetic theory, it states that it also branches off to tell us that this motion can be in different degrees. So some of these matter, they are very free to move. Some of them are not very free to move. While some of them, they just don't move. They only shake or nod their heads. And those are the solids. So then specifically, those matters that move very little, they are known as solids. And those matter that move on an average, they are known as liquids. And those matter that move very, very, very freely, they don't have any restrictions. They are like free beings. So those are gases. So now we're talking about those three forms of matter. Now, solids. A solid is basically any substance which is hard, as we know it. But then there are different types of solid, and there are four solids, such as amorphous substances, which we'll be talking about in another series. But then these solids, they are basically all of them have one principle in common, one property in common, is that they are only free to vibrate. They are not free to rotate, and they are also free to rotate too, but they are only free to rotate and vibrate. So they cannot move about their main position. Just like when I am here I am now, I can be shaking my body, but I'm still where I am. I'm still rooted to the spot, right? In this video, because I'm kind of like a solid. You understand? So that's just I'm giving an example. But if I was moving about from one place to another, that would not be a solid. That would not be an example for solid. But if you are in the same place and you are just nodding your head or shaking your hand, that's a solid. Solids are the phase of matter that have the least degree of freedom in motion. An example of solids are basically your ice. So as I was saying earlier at the beginning of this video, I talked about ice, right? And ice is the solid state of matter, or you can also call it the solid phase, PHASE, of matter. Now we'll talk about liquids. A liquid is basically has an intermediate range of freedom in terms of motion, and those motions are known as kinetics. So and that kinetics of the liquids, they often result in what we know as gas pressure, and that's this gas pressure we'll talk about in this video later on in what is known as gas laws. So let's move on, because these liquids, they have the freedom to move about. They translate, they can rotate, they can vibrate, and they can also translate. But when they translate to restricted extent. And one property of these liquids is that they often take the shape of the containers they are put in. So like if you pour water in a pot, that water, just imagine that the pot is invisible. You will notice that if you imagine that in your mind, you will know that that water will take the shape of that container. So but solids, they often have their own definite shape, but liquids do not have the definite shape. So that is the difference between solids and liquids. So and these liquids, as I stated earlier, they are free to translate to some extent, in addition to the motion that solids have. Next, we talk about gases. And gases are kind of like the free beings, as I stated earlier. They are very, very free to do whatever they want to do. So and these gases, they are able to translate to a infinite region, and they are only stopped by the what they cannot penetrate. So they are only stopped by a boundary, such as a substance, a material they cannot pass through. For example, a cylinder, for example, your gas cylinder. Now if you crack your gas cylinder by, let's hope by mistake, or maybe you've done something silly like that before, and then you see the gas particles moving outside, you can see that at a point in time those gas, they move in random directions, and if there's nothing to stop them, they will just keep moving until there's equilibrium, and that is known as diffusion and all the rest. So now these gases, they have the highest degree of freedom and motion. Next, let's talk about this solid. Let's go back to solids, because solids are very, very important to us, because most of the time we know materials, we understand materials as solids. So if I tell you that a liquid is a material, now you might be doubting, but basically when you see wood is a solid, you are easy to understand. But if I tell you water is also a material, you'll be like, is it a material? So and that this water and these liquids and gases, they are known as fluids, but these solids, they can also be directly known as materials. So and that is in the layman term. There are also different other ways of understanding this. Now, these solid, they can exist as atoms. In the previous video, I said atoms are the smallest particle of substance that can take part in a chemical reaction, just like a representative. So and then we have molecules. I also stated that molecules are the smallest particle of elements that can exist on their own. They are just like the independent teenagers, stuff like that. You get. So and then we have lastly ions. Now these ions, they are neither atoms nor the molecules, but basically they are when you combine two or more radicals. Now a radical, in literary terms, a radical is someone who has lost it in some form or the other. But basically in chemistry, we don't treat our radicals this way. So we'll talk about radicals as basically a combination of two or more atoms that have charges. So and those radicals, when these ions combine together, they form radicals. But a single ion is basically an atom or molecule that carries a charge. Now in the subsequent videos of this series of these crash course in chemistry, we'll talk about charges and ions in proper detail, but that is the extent we can cover in this video. And then we'll talk about gas laws. So now let's delve into gas laws. Now gas laws, as I said earlier, they stemmed out of your kinetic theory and state of matter. And your gas laws, we have basically three major gas laws. Yes. They are actually four, but in chemistry you will only be asked to talk about three, which are the Charles law, Boyle's law, and then we have general gas equation. We also have what is known as ideal gas equation, but it's just like an abstraction of general gas equation. But basically, before we talk about gas laws, let me explain a little bit further into kinetic theory. Now you see, when these gases, they move about, these gases, just like this air is a gas, right? You can't see the gas, but sometimes you can see gases. Those are called colored gases. For example, your chlorine is slightly yellowish in color. So now these gases, when they move about, they are concealed in a container. They exert what is known as pressure. So and these gases, the pressure exerted by these gases is known as the gas pressure, and this pressure is used to understand and to calculate other quantities in gas laws. Now let's move on to volume. A volume is basically the amount is related to the amount of gas that is inside the substance, and the volume is dependent on the pressure, because if the pressure is increased, the volume is compressed. When you compress gas, you are decreasing the volume and you are increasing the pressure. Now next, we'll talk about temperature of gases. The temperature of gases is basically the degree Kelvin at which the gas is operating. And basically, I have to say that the temperature of the gas in Kelvin is a measure of is proportional to the average kinetic energy of the gas. So then more on that later. That will be on thermodynamics, but this is secondary course. So let's stick to our guns. Now, as I said earlier, let's talk about gas laws. Gas laws. The first I talked about was Boyle's law. Boyle, Boyle's law. Then we have number 2. We have Charles' law. And then we have general gas law. Then we have finally ideal gas law. Now I will give a short explanation of these laws, and basically what Boyle's law is trying to say is that Boyle's law is trying to make us understand the fact that the volume of the gas is inversely proportional to its pressure. So what that means is that, now as I mentioned earlier, when you have a gas concealed enclosed in an enclosure or compartment, now when you apply pressure to that gas, the volume decreases, so the gas occupies less space. So that means that as you decrease the volume, the pressure increases. So and that is an inverse relationship between volume and pressure. So in essence, it means that V is equals to K over P. Sorry. So V is proportional to is inversely proportional to pressure, or V is equal to K over P, and that K is also known as your gas constant, which we'll be talking about in the ideal gas equation. Then we also have Charles' law. And before I talk about that, let me emphasize that for your Boyle's law to hold, your temperature has to be constant. So for your volume to be inversely proportional to your pressure, your temperature has to not change. Then let's talk about Charles' law. Charles' law basically states that your volume, the volume of the gas, is directly proportional to the temperature. So that means V is equals to KT. So now what Charles' law is trying to say is that Charles' law is kind of trying to tell us that when you increase the volume of gas, you are increasing the temperature, or rather, or more practically, when you increase the temperature of the gas, you are increasing the volume. So that means basically when you heat a gas, for example, have you heard probably you've heard of or you've experienced circumstances where you heat metals. You have what's known as expansion. So that occurs in solids and gases and liquids too. So not just solids. In physics classes, you talk about expansion in solid, but also gases expand. And when those gases expand, they occupy more volume. So expansion occurs mostly when you heat the gas, when you increase the temperature. So when you increase the temperature, you are indirectly increasing the volume of the gas. So that states that volume is directly proportional to the temperature. Then so we have the general gas law. And the general gas law is no other law than when you combine your Boyle's law and your Charles' law. That means because V is directly proportional to temperature in Charles' law and inversely proportional to pressure, let's say that means V will be directly proportional to temperature and inversely proportional to pressure. So when we combine them, we'll say V is equals to KT over P. That is called the general gas law. And then we have the ideal gas law. So and this ideal gas law says that the volume of the product of the volume and the pressure is equals to the nRT, where these n and r are constant. So an n, your volume is the volume of the gas, V is the volume of the gas, P is the pressure of the gas, n is the number of moles of the gas, more on that later. R is the general gas constant, which is about 0.0082 substance. That's the magnitude of the constant. Then we also have the temperature. So and this is general gas or the ideal gas law. So now basically we've talked about some kinetic theory, atoms, molecules and ions, and then we'll talk about gas laws. And then before we go, let me talk about something I've skipped earlier. Now we said elements, we have elements and atoms, right? Now anytime this element is forming, is on its own, it's called a pure substance. And there are different methods you can use to examine the pure substances. And these pure substances, they have what is called the transition point. Basically, when you move from your solid state to your liquid state to your gaseous state, that is called the transition. And those transitions, they are marked by boiling point and melting point. So one major way that is used by chemists and scientists to know the purity, whether something is pure, is to boil it. And if the temperature of of the substance is uniform throughout the boiling process, it is pure. So that is a general way of testing for purity. So we've gotten there, and in the next video we'll be talking about the mole. Thank you for watching.